Hey, Rockheads, this is Carl Franklin.
And this is Richard Campbell.
Here to announce that NDC is back in Copenhagen, March 14th to 16th at DGIBN.
It's 2 days of workshops and a one-day conference, so go to ndcmini.com to learn more.
Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And we're still in London. You've been listening to us from London for a while now, huh?
Yeah, a couple of weeks shows. Anyway.
Yeah. And we're at NDC, the NDC conference. They do one in London every year. And it's, I don't know, what is this, 5 years that we've been in London?
Yeah, I think this is probably the 5th year for London. First time here in Westminster as opposed to being out in Docklands.
Right. Yeah.
But, I mean, we've been going to NDC since 2008.
Yeah, it's been many years.
Yeah, to the Oslo show, when it was on the old venue and stuff. Like, it's grown a lot over the years.
It's fun to do shows in person, I think, once in a while. You got to get us out of the studio.
Well, it's been great to visit with the listeners. Lots of folks coming up to the door and saying hi. So it's a pleasure.
Yep. Well, I got something really kind of spooky for you.
Spooky?
Today. So roll the music.
It's not October. All right, dude, what do you got?
So this is a story that came out of The Verge in December, around the end of the year. Some Sonos and Bose speakers are being hijacked to play ghostly sounds.
Oh, of course, they're Wi-Fi speakers, right?
Yeah. Researchers at Trend Micro have found that certain models of Sonos and Bose speakers have vulnerabilities that leave them open to hijacking, as reported by Wired. The accessible speakers are being exploited by hackers that are using them to play spooky sounds, Alexa commands, and Rick Astley tracks.
Never going to give you up.
Never going to let you down. So, I mean, it goes on and there's more details, but I think that's enough.
Oh, though the evil one here is smashing glass. In the middle of the night? That's so mean.
It's mean.
It'd be terrifying.
Would be.
Yeah. Oh, my goodness. Yeah.
And we don't have cats. What's going on?
Yeah, you're right. Every time there's a crash in my house, it's a flipping cat.
Well, I grew up with cats. I don't have cats now, but I grew up with, we had 7, I think, at one time.
Oh, my goodness.
And the cats, when they wanted to go out at night, would walk up and down the piano.
Oh, wow.
Ding, 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 ding.
And it works.
Ding. What the heck is going on out there? Source of many nightmares. So that's what I got. Who's talking to us today, Richard?
Very cool. Grabbed a comment off of show 1316, the one we did with Jennifer Marsman, back at NDC in Oslo, 2016, talking about lie detection using Azure machine learning.
Talk about eerie.
Yeah.
That was kind of creepy.
Little creepy tie in there, the emotive headset to do EEG monitoring. I don't know if you've ever seen this.
No.
Particularly, but Jennifer put it on her husband.
Oh, wow.
And asked him questions.
And then asked him questions and watched how his brainwaves reacted and with the machine learning models could tell if he was telling the truth or not.
That is super cool.
That is challenging a marriage in a way. I think it takes a certain level of confidence to pull that off. And John Suda says, this is from about a year ago. Hey guys, thanks for the great episode. At one point in the show, you talk about a situation where, simply put, a machine learning algorithm recommended increased police attention to ethnic neighborhoods. Jennifer said this was happening because the input was biased, and Richard said that it might be a case of self-fulfilling prophecy. I believe that in reality, the algorithm simply discovered a correlation with no underlying causation exists. After all, correlation does not imply causation is a mantra from Statistics 101. Social scientists will agree that the correlation between ethnicity and crime rates does indeed exist. Just look at the number of incarcerated African Americans or indigenous people in Canada. Very high, relatively speaking. And again, this is the point I was making at the time is it becomes a self-fulfilling prophecy when you incarcerate a lot of people and then use data to show, well, we incarcerate a lot of people.
Right.
The question is, are there reasonable incarcerations? And this battle of bias over machine data is hugely important.
Yeah.
John goes on to say, unless you're a white supremacist or racist, hopefully you don't believe that ethnicities are somehow inherently criminal. Yeah, because that would be a bias now, wouldn't it? I wonder if this represents the fundamental limitations of many of these algorithms. They're good at untangling complex relationships between variables. way better than traditional statistical methods, but they can't always conclusively tell whether links are causal in nature. The bottom line, in my opinion, is you still need a human being to perform a qualitative, critical analysis of whatever the algorithm spits out.
The Freakonomics guys showed that it was poverty that was the major factor in people who commit crimes.
If you're going to go down the crime path.
What ethnicity.
Sure.
Yeah.
Yeah. And again, it's, it creates circumstances where people are constantly in need. They will find ways to deal with need.
Right. Yeah.
But it's, and I, challenged John here. This is a comment from over a year ago. You think in the past year and a half, how much conversation we're now having around machine learning and cultural biases, like that these, we've always said this, computers are only amplifiers.
Yep.
And so they, are going to amplify our intelligence, or they're going to amplify our stupidity. And they're certainly going to amplify our biases. So I think in some ways, the fact that this is on the tips of our tongues, that we are talking about this, is the best thing we could possibly do.
Agree.
We're never going to get rid of our bias, but if we can at least acknowledge it and make sure that it isn't amplified by our technology.
And we can compensate for it.
Yeah, in some way. And I'm not going to say it's easy. It's going to be an ongoing process. But if we don't talk about it, we're never going to get anywhere.
True.
So, John, thank you so much for your comment. The .NET Rocks mug is on its way to you. And if you'd like a .NET Rocks mug, write a comment on the website at .NETRocks.com or via any of our social media, because we publish every show to Google Plus and Facebook. And if you comment there or read it on the show, we'll send you a mug.
Definitely follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. We make Alexa say them on our mother's Bose speakers.
That's really creepy.
Yeah. All right, let me introduce our esteemed guest today. Kesha Williams is a software engineer with over 20 years' experience specializing in web application development. In addition to being a software engineer for Chickfila, she trains and mentors thousands of software developers in the U.S., Europe, and Asia while teaching at the University of California. She's authored courses on Java, machine learning, artificial intelligence, and augmented reality. Did her summer internship with the National Security Agency, and most recently won the Think Different Innovation Award from Chick-fil-A for her work on investigating how emerging technologies and AI can enhance restaurant operations and customer experiences. In her spare time, she leads the Georgia chapter of Technovation, speaks at technical conferences across the country, including NDC, and serves as a mentor with the New York Academy of Sciences and conducts free hour of code workshops for children at her local library. Somewhere in there, you've got to sleep.
I definitely do not get the recommended 8 hours of sleep at night. I've given up on that dream.
Wow, that's a
but
lot
also
of stuff.
working on things you really want to work on, which is the best way to be distracted.
Definitely.
I can appreciate that.
Yeah. I mean, I'm just going to give you an open-ended chance to just start wherever you want. I mean, there's
all of these
so
things
much
sound
to talk
awesome,
about.
Kesha.
There is a lot to talk about. Where do I start?
Do you want to dive in on this bias conversation? Like just this?
Sure.
I think it's a huge part of machine learning now.
Right.
And as I said, kudos to John who wrote that 18 months ago when it wasn't as talked about as it is today.
Right. It's definitely still an issue. It's probably going to be an ongoing issue. When we talk about machine learning, it's a very hot topic right now.
Sure,
and definitely machine learning is really the next wave of transformative technology that's going to change society in ways that we can't even begin to imagine. And so my talk was about machine learning and how to build models using Amazon.
Right.
And there is a portion at the end of my talk where I highlight machine bias. For me, I created this predictive policing machine learning algorithm. Just think pre-crime from Minority Report.
Right.
Wow.
And his name is Sam. So SAM stands for Suspicious Activity Monitor.
Interesting.
Wow.
And anyone walking down the street can talk to Sam through Twitter. So you take a picture, you tweet it to Sam. He then uses computer vision to pull attributes from the photo, like age, gender. He gets additional information from the tweet, like location, time of day, day of week, month. All of these, I guess, attributes you can find crime patterns in that data.
Interesting.
And so he takes that and sends it to his machine learning brain that then spits out a prediction that represents the likelihood of crime. So yes, a crime is about to occur, or no.
Right.
And if it's yes, he'll send a tweet back to the user that says you need to run for your life, or you're safe.
Right.
So all that to say, when I created and trained the model Sam, I intentionally excluded race, because I did not want Sam to be accused of racial profiling.
Sure.
And I know it's a very prevalent issue in the United States.
Hot button topic.
Right. And so as the developer, I made the decision to exclude race, to at least have that portion of him be bias free. And this is just something I say to all developers. We have a moral obligation just to make sure that what we develop and what we use machine learning for, that it's really bias free and it doesn't impact or destroy someone's life.
Don't amplify those flaws in ourselves,
Right.
really. Isn't it interesting that that's where we are as developers now, that we have to have moral conversations about how we use technology?
I think, and that requires you to sort of come up with the scenarios that could happen based on what the technology can do and what you're allowing it to do. So before you implement feature X, you really do have to sort of sit down and think about all the permutations of how it could be used for good or ill, right?
Right. And I put that on the developer, the person who's actually building it. So the company that asks you to build this predictive policing machine learning algorithm may not think about the bias and things like that. So really, it's the developer who has to bring that to light and make it a conversation that people talk about.
Yeah.
And I've done some ethics talks around AI, and when I bring up Grayball, this is the Uber tech, the very sneaky piece of software that was hiding itself from regulators and hiding itself from Apple and spying on its drivers and so forth. And and I think it was Grady Booch who actually came out and says, I'm not that angry that Uber wrote this. I'm angry that developers coded it.
Right.
Yeah.
Right.
And my counter argument to that is we do know about it. So maybe someone wasn't able to refuse to make it, but they were willing to leak it. So at least that we knew that this evil piece of software was out in the world.
Yeah.
But I've written code for 40 years, literally 40 years now. And I've never been in a time where ethics was so prevalent in our conversations about technology.
Yep.
Right.
And I guess it's just we've hit a power level.
Right.
We have enough power that it's actually hazardous.
Right.
I'm interested in how your SAM program was used, and how has it been used, and has it worked to stop crimes? What's its success rate?
SAM is a case study.
Okay.
And so I always tell people at this point, because of the data that I used to train him, I pulled data from GBI, Georgia Bureau of Investigation. So SAM works only in the state of Georgia. And I received like the positive records from the GBI. But whenever you create a machine learning program and you use supervised learning, you have to show the positive records and also the negative records.
Right.
So this indicates crime. This does not indicate crime.
Yeah.
And so the negative records I created myself. And so, like I said, it's a prototype. It's a case study in a real world situation. I would want to use real data from, for example, the Atlanta PD. So if anybody out there has a link with the Atlanta PD, please let me know. I'd love to have their data to train Sam with.
Well, you almost wonder if all that body cam data would be useful.
Oh, yeah.
There's a lot of good data.
Yeah.
Yes.
Yeah.
Yes.
Well, a part of the conversation around machine learning has come to this fact that we now have digitized so much of human behavior,
Right.
typically through social media,
Right.
that we have
Right.
the data to train with.
Right. Right. It's
There
amazing.
might be a bias inherent in what people choose to post to social media, though.
Sure.
I mean, really what you need is just random pictures taken for no particular reason and stored in some place.
Well, one would argue using police body cam data would make you oversensitive to crimes.
Absolutely.
That's a policeman's job.
Right.
Right.
Is to be where the trouble is.
Did you know
Right,
that
that's
more
true.
people are more apt to die in an ambulance than in any other kind of car?
Yeah.
Did you know that? So
That's
the
interesting.
thing
Oddly
here
enough.
is, don't ever get a ride in an ambulance.
That is an interesting fact.
Yeah. Like most accidents happen, within 5 miles of your home. That's because where you drive the most.
Yeah.
Oddly enough.
Yeah, that's true.
Very funny. How long have you been working in this space? Because it's new and hip.
It's a long time.
Yeah. So we've all come rushing to
years,
you.
But wow. I've been in IT for 23 years. Wow. And I have the gray hairs to prove that. But I actually started coding in high school. Nice. I was in the ninth grade. I did not realize at the time it was called coding.
Right.
I just called it playing with the computer. So my dad purchased a personal computer to do the family finances, and he put it in my playroom. So we had this room that was a playroom / office. And so I always joke with people, I had Barbie in one hand and I had a computer manual in the other hand,
nice.
writing basic programs. And so, sure. And I'm just very grateful that I had that exposure early on, because if I didn't, I definitely would not have chosen computer science and math as my major in college.
Yeah, but by the time you were even needing to make that decision, you'd already had these experiences.
Yes.
You had a very different relationship with
yes.
with the career that most people are going to have.
Yeah, and he also, in the 11th grade, my father sent me away to a local college.
Wow.
I attended a summer science enrichment training program, and there they also taught me about computers and about chemistry. And so after that experience, it really sealed the deal. I'm like, this is it. This is it. There's nothing else for me.
Awesome.
And so did you get involved in the machine learning side early on?
No. So this is something fairly new, maybe a year and a half ago. And so for me, I am a learner, really a lifelong learner, and I love learning new things. And so being in technology, I always have the opportunity to learn something new. And so machine learning is a very hot topic. And
Hugely.
so I wanted to learn more about it, and specifically how Amazon machine learning works. And so I learn best by doing. And so I needed to come up with a use case, something that I could build. And I'm a huge science fiction movie fan. So Minority Report is my favorite movie. I've seen it a billion, trillion times. And so I started thinking, well, in that movie, they use psychic technology to make crime predictions.
Right.
So what technology do we have today? That's machine learning.
Yeah.
And so I just went through the process of building SAM, and I learned a lot. And then I just wanted to share everything that I'd learned.
How did you improve Chick-fil-A? That's got to be a great story.
Yeah. So I've been at Chick-fil-A for 13 years.
Wow.
So a pretty long time. And there are really two parts to my role. So there's what I call the day job and the night job. So, the day job, that's the boring. I'm a full stack web developer. I work with Angular and Java and Spring. But my night job, I get to lead innovation teams as we research a lot of these cool and emerging technologies like machine learning. We've done some facial recognition, Internet of Things. And so that we just really get to research, and I call it play around and build prototypes, proving out technology. So one team that I led, we used Amazon Alexa to provide an easier way for our restaurant operators to access data, and then for customers to find out nutritional information about the Chick-fil-A products.
Okay.
So we created several Amazon Alexa apps called Skills, and that was the team that won the Think Different Innovation Award, because everyone just thought it was so cool using Alexa to solve some of those business challenges.
I love it as a B2B product, as something inside of the company as an easy way for the staff to interact and get information. I think that's because we always think of it as a B2C play.
Right.
So they had to use it within a business.
Right.
You talk a little bit about that work? Like what were they using it for?
Yeah. So our restaurant operators, we built a skill that allows them to get up to the minute sales. So what are my breakfast sales? What are my lunch sales? What are my drive-through sales? That helps them make decisions on the fly.
Sure.
And then also we created what's called on the clock. So restaurant operators wanted to know like who's clocked in right now, who's supposed to be clocked in and they're not clocked in. So just an easier way to access that type of information. And then for the customer, it's more around nutritional information. Like, tell me about the Chick-fil-A sandwich, how many calories, and things like that.
Sure.
So it was a lot of fun.
It's really interesting. I mean, and I'm just considering when you talk about, dollar figures for sales, does it make sense to do it in a voice form or on some kind of digital dashboard? Like, there's different ways.
We're playing around with that too. Yeah. That was a separate team. They did this what we call the wall board, and so it's really up to the minute information that you can see. Yeah, it starts with gathering up to the information. I love the idea of just being able to walk by and saying to the gizmo, "Hey, what were sales this morning?" Yeah,
and just have that number in your head immediately. I keep thinking in terms of a fast food place where you're always on your feet. That actually sitting down to read something or anything is too long. That the voice would be the fastest way to go about it, but certainly not the only solution.
So if sales were down, would you, I don't know, try to push more milkshakes? I mean,
potentially upsell milkshakes. They are delicious, by the way. Yeah. And, we even looked at what the integration between Amazon Alexa and Ford and a lot of I believe there's one coming with BMW, just still like you're driving in your car and you can talk to Alexa. And as a restaurant operator, you can get that information, even if you're not in the restaurant.
Cool.
Yep.
Yeah.
And hold that thought for a minute, Kesha, while we take a pause for a very important message. When you're building an application, you need it to be fast, secure, and always evolving. With Kubernetes Engine on the Google Cloud Platform, developers can deploy fully managed, containerized apps quickly and easily. Google has been running production workloads in containers for over 15 years, and they build the best of what they learn into Kubernetes, the industry-leading open-source container orchestrator. Kubernetes Engine combines automatic scaling, updates, and reliable self-healing infrastructure with open-source flexibility to cut down development cycles and speed up time to market. Learn more about Kubernetes Engine online at g.co/getgke. That's g.co/getgke. And we're back. You're listening to .NET Rocks. Carl Franklin, Richard Campbell, and Kesha Williams is here talking about AI and machine learning and all sorts of cool projects that she's done. And Amazon Alexa. I mean, Amazon machine learning. There's a lot back there behind Alexa that we don't really know about. And our listeners would love to know. How's that? How do you approach it?
So with Amazon Alexa, well, you first have to figure out what you want to build. Like what value can your skill or your app add? And so once for me, that's the hardest problem. Yeah.
Sure.
What are you trying to automate? What business process are you trying to help? But then once you figure that out, the way that Amazon, the way they set up just the whole process of building an app is really easy. It's very straightforward. So there's a configuration that you do in this front end developer portal that links to your back end, really the brain or the logic behind your skill or your app. And so there are visual tools that help you set that up. And so it's really straightforward. I don't work for Amazon, but I am a huge fan because there are so many services out there like the machine learning, like Alexa and the Lambdas, like the recognition, computer vision and facial recognition. It's just, they're very powerful tools.
Yeah.
And they put these tools in the hands of everyday Java developers like myself. And you can quickly stand up computer vision and facial recognition.
And just API calls or web calls?
Yeah, you can think of it that way.
Right.
Yeah, especially with machine learning. Once you build your model, so that's really the brain or the logic behind your machine learning program, you can expose it through an endpoint URL. So any application that can make an HTTP call can call out to your model and get a prediction.
How much data science do we have to know in order to use these things effectively? Like at what level?
That is a very great question.
Yeah.
So Amazon has many products around machine learning. So if you are new to machine learning, I recommend you start with Amazon machine learning. And so that focuses on just supervised learning, the more basic form of machine learning. And there are visualization tools that kind of step you through the process. And behind the scenes, it does all of the heavy lifting for you. So it picks the learning algorithm based on the type of problem you're trying to solve. And all of that is really abstracted away. So if you're new...
Do they have templates, for example, that you can use for particular solutions that people have already done? Or data sets that you can use that may come from free sources? Or
not for the Amazon machine learning.
No.
Whenever you talk about Alexa and building skills, they have tons of code templates in many different languages. For Amazon machine learning, really you have to have your data already, and you have to go through the transforming and cleaning process. But then once you load it to Amazon, typically in an S3 bucket or in Redshift, it's basically just a click of a button to generate a model.
I understand that, but you have to know which button to click when. And you just load your data and say...
All of that is abstracted away, yes. So you have your data, you load it into S3, and then through Amazon machine learning, you create what's called a data source.
Okay.
So a data source points to that training data. And then in that data, you have... Because it only supports supervised learning,
right,
you have to have the labeled data in there showing the positive and negative records.
Okay.
And then you just click a button that says create ML model. And because you're doing supervised learning with binary yes or no answers, it automatically picks the learning algorithm for you behind the scenes. It really abstracts all of that away.
I'm just trying to figure out how to translate data into a question and answer, right? How does it know what question you're asking? Is it just are you taking a very simple set of binary data?
So, for example, with SAM, so the data that I load up to SAM, it has all of the attributes that you can find patterns in crime. So, like age, gender, time of day, day of week, month. Right. County, state. And then also in that same data set, there's the target attribute. So I call it crime committed. Okay. So 0 for no, 1 for yes.
Okay.
And so then when the model sees that data, it knows it's solving a binary yes-no classification problem.
So one of those fields is going to be the output,
the target
that you're going to query about.
Yes. And so Amazon machine learning only supports that type, that supervised learning.
And what is the opposite of supervised learning?
So there's supervised learning. There's unsupervised learning, and that's the ML machine learning that really causes the most buzz in the industry, because the data is not labeled, and it's like the machine is kind of going in blind and has to figure out and cluster and group and segment. That's really cool. So Amazon machine learning does not support the more complex unsupervised learning. But Amazon recently released at reInvent SageMaker. SageMaker. Okay. So SageMaker handles more of the unsupervised, more complex type of machine learning.
Okay.
There's also reinforcement learning that falls really in the middle between supervised and unsupervised, and there is some feedback given to the machine as it's learning. If you're new to machine learning, I highly recommend that you start with something simple like Amazon machine learning.
Sure.
You get those concepts and you understand how supervised learning works, and then you move up to the big guns, and that's SageMaker, where you can use unsupervised learning.
Because Amazon's always had sort of a big third-party ecosystem, stuff like CTNK and TensorFlow, and those are pretty darn advanced tools.
Yes, yes.
TensorFlow is a Google tool, and normally you would run it on Google's cloud, but you can run it on Amazon's cloud if you want.
Yes, yeah.
Do you go down that path? Are you guys, you're happy with the supervised learning for the stuff you've done so far?
Well, at Chickfila, we've dabbled more with unsupervised learning, and really we have all of these customers, and we have our customer data, and we wanted to go through the process of figuring out, like, who are our customers. And
relationships that aren't obvious. We used to call it data mining back in the day.
Yeah. And so we used unsupervised learning to help us really segment our customers. So like this group, working professionals, students, stay-at-home moms.
And I presume you put the labels on it. The unsupervised learning creates the buckets and goes, well, there's clearly a delineation here. Exactly. And then you can look at it and go, well, this looks like professionals, students.
Right. Yeah. And so that's where we actually, the end of last year, we started playing around with unsupervised learning. So we recently opened this innovation lab in downtown Atlanta, separate from our support center. And so we've partnered with Georgia Tech, which is a really good school in Georgia, and we really work with interns. So we think of it as year-round interns. And so we had 4 students come in for the first session, and that was one of their projects. And I helped them just through that process with the unsupervised learning. So it was a lot of fun, and it was fun to step outside of my normal day-to-day activities and get to mentor and work with students, and then also learn more about unsupervised learning and applying it to the business.
That's very cool.
Yeah, it was a lot of fun.
Very cool. Well, Richard.
Yeah, buddy.
Guess what time it is now?
It must be that happy time again.
Yeah. It's time to read the results of an Amazon machine learning algorithm that I wrote that predicts how funny this joke is going to be.
Oh.
And the result? No input defined exception.
Nice.
Uh-oh.
We need data first.
Oh, yeah, that's right. No, I'm sorry. There's no data. Okay. It's actually time to give away a DExperience subscription from DevExpress to one lucky member of the .NET Rocks fan club. Become a UI superhero with DevExpress UI controls and libraries, and deliver elegant .NET solutions that address customer needs today and leverage your existing knowledge to build next-generation touch-enabled solutions for tomorrow. Whether it's an Office-inspired application or a data-centric analytics dashboard, DevExpress Universal ships with everything you'll need to build your best without limits or compromise. And check out their DevExtreme React Grid, built from the ground up to fully support all the cool features that come with React, like the virtual DOM and state controllers like Redux. It supports master detail, sorting, grouping, paging, and editing. And you can check it out and test it for free on GitHub. But learn more and download your free 30-day trial of DevExpress Universal at devexpress.com/superhero.
All right, buddy. Who's our winner?
Today's winner is Frederick Fall.
Congratulations, Frederick.
Yes. Golf clap for you, sir.
Golf clap for you.
Frederick just won the DExperience subscription, a big pile of awesome from our friends at DevExpress, just for being a member of the .NET Rocks fan club. And if you don't know what that is, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world, and every show we like to give away stuff from our sponsors. And every December we give away a $5,000 technology shopping spree to one lucky member of said fan club. But you do have to sign up to win. And we also like to ask our guests, Kesha, if you had $5,000 to spend on technology today, what would you buy?
Very good question. So, my dream for Sam is to have a drone.
Oh, my.
Wow. Good idea.
Serve as the camera.
Right.
For Sam.
Yeah.
And I just imagine the drone.
Just send it out for a ride.
Yeah.
Yeah.
Yeah. And the drone is taking pictures. So I would definitely buy a state-of-the-art drone.
Yeah. That is a great idea.
Something like a DJI Phantom 4.
Oh,
like,
yeah.
Just a few $1,000, beefy.
Yeah.
You know what we haven't done yet in drones is have them be able to go change their own batteries. To go fly to like 25% power and then go back, land somewhere where they can drop a battery, pick up a new battery, go again.
Yeah, it's that whole what happens after you eject the battery problem. Yeah. Right? You're going to have at least some power in there to put the new battery in.
Yeah, there's some mechanism.
I do remember hearing a story about this guy who worked for the military, I think, and then he got off on his own and he built this super high-flying spy plane camera that had ridiculous resolution, and it flew up so high that you couldn't see it. You couldn't hear it.
Wow.
And it went over, I think it was in Chicago. I think it went around Chicago.
Oh, I have to Google that.
Yeah.
And it was recording all the time and kept about an hour's worth of camera shots recorded. And then whenever there was a crime, they would find it, and then you could zoom, scroll back the recording to see where the cars came from, where the house is, and then they would use it and go bust the people that committed the crime.
I love stuff
right
like
away.
that.
It was awesome.
That is awesome.
But, you could do the same sort of thing with the drone. So as far as it doesn't
It sounds like what the military does with their Predator drones, right?
Yeah.
Flying basically out of sight, although sometimes you can hear them.
Yeah.
They
But it's also
they just throw the missile in it as well.
Yeah. It's almost an unfair advantage, though.
Yeah.
And then, of course, the privacy concerns.
Yeah, there are a lot of privacy concerns.
Talk about moral dilemma.
Yeah,
it's like
there's a lot of good conversation.
Effective like crazy on catching criminals, especially murders and stuff. It's like,
but we have cameras all throughout our cities anyway.
Right.
It's not that we're not on camera.
That's true.
It's what happens with the data.
Yeah.
That's true.
So, the idea that we're collecting the stuff but not using it unless there's a case to be had. I don't want to go so far as like you require a judge's order, but it's along those lines of we know that an event has happened in this location. Now we look at the data.
Right. And I've heard of some countries that they've actually weaponized drones. And so when you think about that and you couple that with computer vision and machine learning, you'll eventually, if we don't today, you'll have drones that they're able to make decisions on their own without human input.
I saw that video too.
Oh, you saw that? Oh, yeah. But it's true. I mean, it's like, it's where we're headed if we're not there already.
Yeah. Well, and it's been a conscious, certainly in the U.S. military circles, they've been keeping a human in the loop. But the machine's able to get to a point where I think that's a target, and so forth. There's still somebody in the end going, prosecute that.
Yeah.
Which is great terminology for hiding the fact that you're killing someone.
Yeah.
Yeah.
And I don't want to go there.
Yeah.
I'm keen on stuff like Sam, just this idea of giving a police officer a chance to be in the right place at the right time.
Right. Or even, alerting him.
Yeah.
Right.
Like, this is where you need to go. There's something that doesn't look too right going on.
That things are going on. And certainly with the events in Las Vegas, we talked to Tim Huckabee about this, where they're talking about the cameras that also count crowds, but would show odd behavior.
Okay.
You think about casinos; they have cameras everywhere all the time, but they're watching for people trying to cheat in the casino, not keeping track of the fact that this person has carried a large duffel bag up into the elevator a dozen times.
Right.
And if the software could get to a point where it's saying, you should look at this.
Right.
Yeah.
To do that collation so that you can say, hey, here's over a span of days, the same person doing the same thing over and over again. This is odd.
Right. And
maybe probable cause for it. Let's go take a peek in that room.
Right. It's just, for me, it's a very exciting time to be in technology.
Yes.
I want to jump back to the conversation around unsupervised learning, because it's interesting when you talk about those buckets, that the buckets were jobs, that they were student, professional, and so forth. Like we talk about bias. In theory, you're talking about an unsupervised system where it has no bias. Would it bucket to jobs? Would it bucket to income level? Would it bucket to ethnicity? Like, what are the stratifications? And then we get into the risk of bias and those sort of effects. And how do we control that in an unsupervised learning scenario?
Right. That is a very good question.
Part of me says, let's not collect the ethnicity data.
Right.
The best way to steep that from showing up is to stop there.
Yeah.
Right. Even in an unsupervised scenario, you're still deciding what data to feed the system.
Right. So that would be a good way to control it. I'm trying to think if there's any other way.
It's just, we accept the idea that you're going to bucket into work role.
Right.
And the whole point with an unsupervised system is it's going to bucket in a way you haven't thought of before.
Exactly.
That it'll come up unlikely.
Right.
And I just wonder what that would be. And you're afraid to exclude any data because you never know what the correlation might actually be. Yeah. So it's an interesting challenge.
It is a very interesting challenge. And just bias in general.
Mm-hmm.
Yeah.
And it's not just racial bias, it's age bias and gender bias. And how do you, especially when we talk about predictive policing and machine learning, how do we truly create models that are fair and don't have some level of bias? It's a great challenge.
And there was an argument in the beginning of profiling that said this was a way to optimize.
Right.
It just became evident that it was an unfair way.
Right.
That it was, again, a self-fulfilling prophecy. A police officer has a certain level of discretion of identifying crime, and when that bias creeps in, you're being unreasonable.
Right.
It's easy to have that happen. I think and I'm just fascinated by the prospect of could the machine do a better job? It'd probably do a consistent job.
Definitely a consistent job.
But it could be consistently bad.
Yeah. It just depends on how the developer trained that system and how it's coded. With predictive policing, there was an article that Stanford released. I believe it's called Artificial Intelligence and Life in 2030. Mm-hmm. But it just says, like, in the next 15 years, we will heavily rely upon predictive policing.
Wow.
And so that's good and that's bad, because when I think about it, what are these models looking at when it predicts crime? It's like a black box.
Yeah.
I don't know.
Yeah.
You're getting into the big issue around deep learning that folks are talking about. Most of the machine learning models, and we've talked to Seth about this and others, they're mathematical. You can decompose them in a way to show this is why this model came to this conclusion.
Right.
But these deep learning models, they're opaque.
Yeah.
It's really hard to understand why they've come to the conclusions that they've come to.
And even more importantly, even harder to use once we know, especially we give them any kind of autonomy or power to make decisions. I'm thinking of the what was it, the Wall Street crash that happened in 20 minutes, like billions.
Flash crash.
Flash crash, right? That all happened because of automated systems. Automated trading, and nobody knows why.
Yeah.
Right.
They don't know what happened.
Yeah.
Yeah, so we're building stuff that we don't even understand.
Yeah.
Right.
Well, you can't look at a log file. You can look at what happened, but the decision-making process, because of the way these neural networks, is really, and I have been reading some interesting papers around, they're coming up with mechanisms to instrument the neural net so that you can derive some consistency behaviors.
That'll slow them down for sure.
Well, without a doubt. But one thing we've got is more compute.
Yeah.
The bigger thing here is, how are we as a society going to be comfortable in trusting decision-making capabilities until we can present it to a judge? This is why it made this decision.
Right.
Like, I think it's a reasonable request.
Absolutely reasonable.
I do too.
And necessary.
But even when you take the decision-making ability off the machine's hands, when you've got software that makes it predictive, that says this is likely a crime, I don't know how many people are even going to question it. Even though we're ultimately choosing to act, when we present a piece of technology that has derived a decision, effectively the decision's still made.
Well, and what you're talking about in predictive policing just diverts the attention of the authorities to the right place at the right time. It's not like it's going to automatically send out a drone and shoot somebody who they
not yet.
But you know what I'm saying?
What if the answer was
if I
tase
had
everybody?
$5,000.
Tase everybody.
Tase everybody, and we'll sort it out later. Everybody do the floppy chicken. We'll sort it out in a minute.
Do the floppy Chick-fil-A.
Well, the scary thing, if you ever watch a tasing hit, is they drop so hard, like people get injured in the fall.
Yeah.
Right? Irrespective of the fact that you just had a whole bunch of electricity pumped through your body, which is not good.
Yeah.
It's, I'm being silly. Please don't do that. Like,
don't do that.
That's not a good idea. But that's, again, how many times have we written software that provides information to people that they simply take as gospel and start to act, and we have made a mistake?
Right. There always needs to be some level of human involvement.
Right.
especially with machine learning. So, for example, outside of predictive policing, it's also used in making like loan decisions. So if you apply for a car loan or a home loan, there may be a machine learning program running in the background that says either yes or no. And so if it says no, that shouldn't be the final answer.
Right.
A human should come in and look at it more and say, well, even though the model says no, XYZ, this person really should, get the loan.
Right.
So we just always have to have that level of human interaction.
Yeah, and I do see that you want automation to solve the easy cases.
Right, right.
The standard red flags of there's just no way we can lend you money, or the standard, you're probably fine. It's the gray area where you maybe want a human's discretion.
Definitely.
When you could take using Pareto's law, take 80% of that workload off in automation and leave the 20% that is harder.
Yeah.
Right.
That needs more judgment for one way or another. And I would hope that in the case of policing, there's always more judgment.
I would hope so.
Yeah, me too.
But it is challenging.
Is there anything, there's lots of stuff here just in your bio that we could talk about, but any particularly interesting stories come out of your work with the NSA?
Well.
Does it stand for no security anymore?
Well. I'm not allowed to talk about that now. I'm just joking.
It's probably fair. Generally speaking, with those three-letter agencies.
I do not want to go to jail.
Yeah.
I do not want to die. So
we're going to leave that alone. Just walk on right on past that.
It was a fun place to work, though. I can say that. It was
a
lot of fun.
I've heard stories that just like a really brilliant group.
Yeah, it was a lot of fun. That's where I started my career.
Yeah. No kidding. And an interesting place to end up. Well, they were also back in the 80s and stuff, the first OLAP technologies that we saw in the world, these original data analytics tools, that's where they came from. The rock stars in that space when I first got involved, they were all ex-NSA guys. So they made companies around it and made product around it.
Yeah.
Sold them and grew them. So I've often thought of those are the places that are trying the next level stuff that will eventually come out
exactly. That's how it works.
Into the consumer space.
That's how it works.
Into commercial space.
That is how it works.
So, very, very interesting.
So pretty much I'll be able to remote into any desktop that I want to and just without their permission. No, I'm just kidding. Who would do that?
Because I know nothing, I'm perfectly happy to make some guesses, but I would bet if there's actually a working quantum computer anywhere, it's
probably
at the NSA,
yeah.
And it's working on cryptographic cracking.
Yeah.
That to me would make perfect sense. It's in their bailiwick.
Right.
They're the ones with the outrageous budgets.
Right.
And the companies that you look at that are experimenting in this space are generally running into money constraints, and these guys are not ones that have that. So it's like, if it's solvable with the brute force of many dollars, they have solved it.
Yeah.
There's a language Microsoft came out with that's some sort of quantum.
Yeah, because they're getting closer to their own machines, so they're starting to come up with toolkits to be able to experiment with quantum programming models.
That's the question I wanted to ask you, Kesha. Speaking of toolkits, that triggered it. What kind of tools do you use to clean data before you, send it up to your ML algorithms?
So specifically for SAM, I did that myself.
Really?
Yeah. So it was a very manual and very time-consuming process.
Wow.
And really, in building SAM, that was the most tedious piece of it. Just getting the data in a format.
Manual, how manual are we talking? You popped it up in Excel and edited rows and columns?
Yeah.
Wow.
Yeah. And so, like with the crime data, I wanted to split out the date. So I wanted to be able to find patterns with certain months, certain days of the week. And so I had to manually split that out. Now, there may be a better way of doing it, but it was really my first learning experience. And so I enjoyed it.
Yeah.
So,
yeah.
And I do think it gives you a level of intimacy with the data.
I definitely understood the data.
We did a show with Rob Connery earlier in the week, and he did a book around doing data analytics with Postgres. And a part of that whole conversation was he was cleaning up NASA data.
Oh.
And that same sort of, but the process of doing that helped focus in on what these values actually mean, how they work, what a good value or a bad value, We always, whenever we talk to folks who are dealing with data science, they're like, hey, 80% of the time is messing around with this data.
Oh, yeah.
And part of it's just like, wow, is our data that crappy?
Yeah.
Or is it actually, you kind of need to get to know it.
Yeah, you definitely have to get to know it. Like for me, after creating SAM, I totally understand what crime looks like in the state of Georgia. There are certain patterns like July and August, highest crime.
Interesting.
Yeah.
It's because being that hot makes people crazy?
You stole my line. That is exactly what I say.
It is Hotlanta after all, right?
And then there are certain counties, like stay away from Fulton County.
Oh, my.
It's like most of the crime happens in Fulton County.
Wow.
And then you come down to the county where I live, Fayette County, it's like the least amount of crime. I'm like, yay, I picked a great place to raise a family.
You learn that data after you live there. So that worked out well.
Yeah.
That's very interesting.
Mm-hmm.
Awesome. Is there anything else that you wanted to talk to us about, particularly, before we wrap up?
Well, I will definitely give a plug to Technovation.
Okay.
So it is a global computer programming competition for girls, and I lead the Georgia chapter.
Yeah.
And so we target middle school and high school girls, and we teach them about computer programming.
Cool.
So it's just really, for me, because I was introduced to computer science so early on, it was like a no-brainer when I was getting ready to go to college. And so that's really what I'm trying to do, just to expose girls to what's possible, really help to increase the diversity in technology. And so it's an awesome competition. It's all free for the girls. We really live based on like sponsorship. And so we take them through the whole process of trying to solve a problem in their local community by building a mobile app.
Wow.
So we talk them through prototyping, we build a prototype, and then building a system, and then testing, and then at the end, pitching your app and your business plan to a panel of judges. And so the winning team walks away with a cash prize. So can you imagine being in high school and you have $25,000 cash prize?
Yeah.
So it's an awesome program. It's worldwide, and so I just want to put a plug out there. If we're always looking for mentors to help work with the girls, and then we're always looking for girls who want to learn more about computers.
Awesome. And I think back to the show we did with Jennifer Wadella, and we were talking about sort of breaking through the social stigma that's keeping girls away from technology.
Right.
And because you got in so early, like you weren't at the social stigma level that concern when you already knew it. By the time you even could consider the social aspects of computing, it was part of your life. Right. It was already there. Right. It begs the question, like, shouldn't we just be introducing this earlier?
We should.
We more of that.
Definitely.
We should.
That this is an elementary school thing.
Right. And I'm very excited now. I have 3 children, 16-year-old boy, 14-year-old boy, and a 10-year-old girl. So my 16-year-old, he's in 11th grade, and he's actually learning Java in high school. So he's always texting me, how do I do this in Java? How do I do that? And I'm like, I wish I had something like that when I was growing up, because like Java in high school, really? Yeah. That's amazing.
Production languages, I love it.
Yeah.
My next door neighbor has a kid, and he was about 10 when I first met him, and he was taking Java in school.
That is amazing. That's amazing. Yeah.
So he would come over and play with my HoloLens all the time. All the time. Yeah. Coolest neighbor award.
That's you.
Definitely.
All right.
Well, thank you so much for being here.
My
and spending this time
pleasure.
with us.
Thank you for having me.
Fascinating what you're doing, and check in with us from time to time.
Definitely, I will. Thank you so much for having me.
Okay.
A lot of fun.
And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got a transmitter banned by the FCC. Yes, I'm a toy boy. Life is hard.